Well, good evening, everyone. My name's Jeff Mitchin, Senior Agricultural Advisor with the Local Land Services Drought Adoption Officer Program, and I will be your host for this evening's webinar, which is a state seasonal update, given the current, having a look at the current seasonal conditions across our state. Just to kick off, we'll do our normal acknowledgement of country. So Local Land Services acknowledges that it stands on country which always was and always will be Aboriginal land. We acknowledge the traditional custodians of the land and waters, and we show our respect for elders past, present and emerging. We are committed to providing places in which Aboriginal people are included socially, culturally and economically through thoughtful and collaborative approaches to our work. Just a little bit of housekeeping on the webinar tonight. For the best experience, we recommend either joining by a desktop or laptop computer. This session will be recorded, so it will be available on our YouTube channel as soon as we can get it there for viewing or sharing. If you have any questions through tonight, please use the Q&A function, which is at the top of the screen. In the taskbar, and at the end of the session we'll make our way through those questions as they come through. If we don't happen to get through all the questions, we'll endeavour to get some a Q&A sheet back out with the webinar recording. And also at the end we'll have a post-event survey, so please we'd really encourage you to fill that out so that we can improve what we do and meet your needs. So tonight's speakers, I'll be your facilitator, as I've just said. We have Anthony Clark from Department of Primary Industry Research Development, who is the leader of climate applications, and he will run through an introduction and overview. Have Kel Langfield, who's their engagement specialist, who will provide a seasonal update and some local insights. And then we have Jennifer Wurzel, who's a research officer climate applications, and she will run through forecasts and some outlooks into the season. So with no further ado, we'll hand over to Anthony.
Yeah, thanks for that, Jeff. I'll do an introduction while Kel's setting up the slide deck for tonight. First of all, just a sincere thank you to everyone for joining us. We really appreciate your time and attention. Tonight's presentation, we're going to focus on two main things. We're going to do an overview of conditions across the state. We're going to drill into some regional examples. We're going to have a look at a broad range of data that goes into doing the seasonal conditions assessment. The second major thing, we're going to spend quite a bit of time focusing on forecasting. As everyone appreciates, it's a really important window at the moment for everyone. In autumn, people are strategizing their production for the year, pretty much right across the state. So people are in that real decision-making mode. So the forecast has a high degree of relevance. My team has the job of monitoring seasonal conditions across the state. The department and its precursors have been doing that for quite a long period of time. It actually dates back over 20 years. In its current form, our main product is a report which we publish each month called the New South Wales State Seasonal Update. If you haven't subscribed to the State Seasonal Update or the SSU, I please encourage you to do so. The SSU is free. It goes from everyone to the minister. A lot of industry bodies use it. A lot of regional organisations and community organisations use it, as do a lot of farmers. All of the information that you're going to get an overview of tonight is in the State Seasonal Update. This month's State Seasonal Update was supposed to be published at 3 o'clock this afternoon. Unfortunately, due to some technical hiccups, it will be published tomorrow morning. So people on this webinar are going to get an early insight. Look, that'll do for an introduction. Like to hand over to my colleague, Kel, who's going to give an overview of conditions across the state.
Great. Thanks, Anthony. And yeah, again, reiterate, thanks everyone for joining us tonight to get a little bit of an insight about how our data works and what we're seeing across New South Wales at the moment. So we thought we'd start with a rainfall update. So what I've done here is I've just looked at autumn to start with. So basically the 1st of March through to the 3rd of April. So on the left, we've got our sort of those rainfall totals that we've seen across the state. And on the right, we've got a rainfall anomaly map there. So that anomaly compares that time period, so the 1st of March to the 3rd of April, with our long-term baseline that we refer to, which is from 1981 to 2020. So you can see that where those higher totals have been in southern and western areas of the state through autumn. So they've had, in some cases, quite a really good autumn break, particularly in the far west. A slightly more moderate autumn break in the south, but there has been one. The thing that's sticking out for us at the moment is the significant deficits in the north and the east. So right up through central west, northwest, across to the east coast, the far north coast there. So some quite significant deficits there at the moment, particularly for April, particularly for that part of the world. If we move ahead then and look at year-to-date rainfall, so we're again starting from January through to the 3rd of April, you can really see those high totals there along the coast and some really high totals for Western New South Wales. If we've got some people from that part of the state, or of those who've been following the weather, they had some significant events in February and March, which has really sort of boosted their season out there. This is a different map that we also produce, which is called rainfall percentiles. That's the one there on the right. So it's ranking from 0 to 100 and comparing this time period against our baseline from 1981 to 2020. So the blues are those ones that are well above sort of median, or those higher percentiles, and the reds and the oranges are the ones that are really low, comparing that time period. So that deficit, which was reflected in that anomaly map on the previous slide, has been reinforced in this year-to-date rainfall percentiles. And if we'd gone back into late 2025 or even back as far as October, that deficit's been there for quite some time. So the northern part of the state, in contrast to the southern part of the state, has seen quite a dry period. One of our shorter term indicators that we use to help track drying or wetting trends is this soil water figure. So what we've got is just 2 time periods here. So it tracks the shorter term changes to soil water and combines that with some of our other maps so that we can start to see what might be causing these changes. Is it rainfall? Is it something else? So it's a 21-day figure, so it tracks 21 days back. So the figure on the left was the 21 days up to the 31st of December, and the figure on the right is the 21 days up to the 3rd of April. Just to show you that contrast, so you can start to again see back in December, the western part of the state and parts of the southern had very low soil water values for that 21-day period. But then as we move forward and look at the 21 days to the end of to the 3rd of April, a change. Those deficits that we've been recognising for the northern part of the state there are quite clear, and those areas that have had those really high rainfall totals, particularly recently through late March and into early April, they're seeing a higher value for their soil water values. So this is a modelled root zone soil moisture in millimetres that's comparing that site there and that soil type to what its water holding capacity would be at that location. So for that time period. So if you're seeing a very low or very high value, and say, for example, that soil could hold 50 millimetres of water and the value at this point in time is, say, 0 to 10, it's holding a very, very low amount of water at that point in time. Our underlying indicators, these are the map view. I'm just going to quickly show you the map view of the 4 indicators that we use that underpin the combined drought indicator, which we'll cover in a minute. So the colour scale for each map transitions to a grey scale at 30% there, the 30th percentile, and that's one of our thresholds that we use to monitor drought intensity. And that's the threshold where an area will move from non-drought to drought affected. And then we go even lower with that grey scale down to a very almost white, and that's the 5th percentile. So the lowest values we nearly can see to delineate drought and then through to intense drought. So this is a map view of soil water, rainfall. Then we have plant growth. Then we have soil water. And again, you can start to see where some of those deficits are quite clearly at the moment. And then we go through to drought direction. So this one tracks the 150-day trend of that rainfall index. So you can see where those wetting trends are, and you can see where those drying trends are. And again, in these indicators, that pattern that we've been observing, driven mainly by rainfall, but there are other influences from the warm summer and the warmer summer and the early water weather as well have also been driving some of the conditions that we're seeing. So using that previous information, it starts to build a picture for what we're looking at when we look at current conditions. So this is our combined drought indicator, which is the public facing figure that most people are aware of. And just quickly before we move forward, just to note about how rapidly things are changing at the moment. So on the left there, I've got the combined drought indicator for the 3rd of April. And on the right is the combined drought indicator from the 31st of March. So even in the last few days, we're starting to see areas slip into drought affected at quite a rapid rate, particularly in that northern part of the state there. So basically summer rainfall deficits that I'm talking about, and these drought conditions are starting to be reflected in central right through to northern New South Wales. Experiencing that rainfall deficit and a dry summer, and have yet to, as I mentioned, receive a substantial autumn break. There's still this rapid deterioration in many regions with declines in key agronomic drought indicators like pasture growth, and we saw that in that statewide map, but I'll go into a little bit more detail on that in a minute. And key areas like the Liverpool Plains, part of the Northern Tablelands, and into the Western Hunter now, Central West and Northwest, areas around Walgett and Coonamble are really starting to see, and have been for quite some time, experiencing this drier period, which is now being reflected in our data. You go a little bit further south, it's a little different. You can start to see those areas, those lighter green regions are in recovery, but it's different compared to where you are across, southern Western or the Central Tablelands at the moment. There was that early autumn break that we mentioned with some follow-up rain, depending again where you were in March, particularly in the west, as I mentioned, and that's why we're seeing a really strong response in our indicators and that transition out of drought affected into recovery and into non-drought, particularly in the west. The Murray, Riverina and parts of the Central Tablelands been in prolonged drought for quite some time, and again I'll cover that briefly in a minute. But there are pockets now that have seen that follow-up rainfall and have started to move into a recovery phase at the moment. It's probably important to note that farm conditions remain highly variable across the state, and many producers who are really focused on autumn production decisions would be really still relying on further follow-up rainfall through autumn to build soil moisture and sort of reinforce that recovery that we're seeing, particularly in the south, and start to shore up things like cropping decisions and pasture growth, pasture sowing coming into winter. As I mentioned, I'm going to try and take a little bit of a zip around the state and look at a couple of locations in a little more detail. So we're visiting a few locations. I'm going to start up north. The figure on the right is what we call a time series chart, which tracks those underlying indicators that I showed you in that map view a little bit earlier there. So the green line is plant growth, The purple line is soil moisture or soil water, and the blue line is rainfall. These give us a much better understanding of how conditions are changing and evolving over time. Basically, where those indicators are positioned on that chart drives the coloured bar at the bottom and shows the transition from one drought category to another. And it really demonstrates the usefulness of these time series, not only for us who, we're just using this data, we don't get out as often as we like, to try and get a feel for what's happening on the ground. As a user, or as a producer, as an advisor, they can start to give you a feel about what's happening by simply looking at the trends of the lines, how they're tracking. So for myself, if I was looking at this for Tenterfield, which is our first location, and then looking at what's been happening over the last couple of years, my brief analysis would be that there was a very strong, solid production period through much of 24 and into 25. But that longer term rainfall deficit starts to become apparent sort of in early 2025, where you can early 2026, where you can start to see just a slight dip in those indicators, but then a very rapid decline in the rainfall index, which is indicative of the rainfall deficit that part of the state's been seeing, and also reflected in those shorter indicators that I showed you there earlier. So again, just reinforcing the usefulness of these time series in conjunction with other data sources that you're using can really help to provide, greater insights into what's happening. If we move down into the Central West and have a look at Gilgandra, again, a similar story through 24-25, that strong production period, or good production, but then we can start to see where rainfall was not sufficient to maintain soil moisture from around September 2025. So you can see that there were rainfall events. The rainfall indicator remained reasonably stable at that time, but soil moisture started to dip. So that kind of gives me the impression, or gives me the feeling that, conditions are starting to slip because the rainfall isn't sufficient. And then again, as we saw for Tenterfield, a sharper decline in the indicators and a dip into drought affected there for a short period of time. But then there was a little tick of rain that was enough to drag it back out, but it now slipped back in again. So it's a combination of that warm and hot summer, insufficient rainfall, and now this sharp dip and a transition back into drought affected. So again, we would be seeing that, and producers on the ground were probably starting to notice that around October last year. I won't go through each of them in great detail, but here's Menindee in the far west, an area where we saw a prolonged period of drought affected, and then those really big rainfall events in February and March, which have caused that rapid transition out of drought affected into recovery and now into non-drought. So these indicators can respond. There's always a little bit of a lag, but that rainfall through February and then into early March, you can then start to see that response in the rainfall indicator and the subsequent response in soil moisture and plant growth. So on the ground, producers out there would be, starting to focus on a pretty good autumn coming into winter. It's a different environment agronomically and agriculturally, as we know. So those rain events were significant, and we'll set them up for quite some time through winter and probably into early spring in that far western part of the state. And then just quickly looking at an area that's been in, experiencing prolonged drought conditions for a long time. So we're going back to April 2024. So this region's been in drought affected and drought for that entire time. Quite simply, the rainfall over time, the indicators responded every now and then back in sort of October 2024 and again in sort of September 2025. And there would have been a visual response on the ground. Last year there was, what was called a green drought, so there was a pasture response. But again, you can see that rainfall wasn't sustained, and we couldn't sustain that recovery or that response that would have led to recovery with further rainfall. So unfortunately, that area remained and slipped back into drought-affected or a more intense drought-affected category, leading through to sort of the end of March and into early April. And finally, just a quick summary. We've got that sort of combined drought indicator there for the 3rd of April. This is a figure that we use to sort of give us a good picture of how conditions are changing. And we can also see the duration of drought conditions across New South Wales with this analysis. So the really dark colours show that with our analysis and with our data, there's been areas there that have been in drought for sort of 2 years plus. But as you go up through the central and into the northern part of the state, it is reflective in the data that, you know, those areas have probably been experiencing drought for up to 3, or drought conditions for up to 3 months there, sort of in the northern part of the central west up into the northwest and across into the tablelands. So that's my brief analysis and update for seasonal conditions. I'm going to hand over to Jen now to run us through the seasonal outlooks and forecasts.
Thanks, Cal. Yeah, so before I jump into the outlooks and forecasts, I thought it'd be worth doing just a 1-slide brief overview of how these types of seasonal forecasts work. A forecast model is run a number of times to capture a range in likely conditions. So on this figure, all of these blue lines are representing these different runs of a single model. So on the left, you have the first day of the forecast, and you can see that all the lines don't start at quite the same point. There's a bit of spread to represent some minor variation in starting conditions. And at the right, you have some time in the future, let's say 3 months ahead, and you have the final outcomes of all of these model runs. And in this example, most of the forecast runs cluster on some answer in the center, and you have a few stragglers above and below that, that central tendency there. And these all represent the range of possible outcomes. So how does this translate to the information on the maps that we're about to see, which are the Bureau of Meteorology's chance of exceeding median maps? So what those maps are saying is that, Kelly, can you give me a click? Yeah, this is the usual rainfall that we get this time of year, the historical median. And what percentage of these lines are below or above this median line? So if you have 70% of the runs above the median, you have a higher chance of exceeding median rainfall or temperature. We'll use rainfall in this case. So you might have more blue colors on the map if it's rainfall. However, in this example, 30% of the forecasts were below median, and these are still realistic possible scenarios that can happen. If they do happen, the forecast isn't wrong. It did predict that range of possibilities. It was just a bit less likely than the other scenario. So now going to a practical example, a real example, this is the 3-month rainfall outlook for the upcoming April to June period. So we've got the outlook on the left and its corresponding accuracy on the right. So thinking back to the last slide, we have a situation here where a higher percentage of the model runs are predicting below median rainfall for this period. So the Bureau's model is currently showing this increased chance of drier than average conditions across the state, with that likelihood increasing in the center and the south of the state. It's a bit closer to 50-50, 45-55 along the coast. And just a reminder here that this is showing the likelihood or the probability of being drier than average, not how dry it's going to be. Next slide, Kel. So if we break the forecast down by month, April has around a 70 to 75% chance of being drier than average across the state. Again, with a little bit less certainty along the coast in the northeast and the southeast. Now, as we move into May, these lighter brown colors indicate that as we are forecasting further ahead in time, there is a bit less certainty in that forecast, but it is still more likely to be drier than average than wetter than average. Looking at here rainfall extremes, this is the chance of being unusually wet or unusually dry. So that's defined as being in the highest or lowest 20% of historical data, of the historical range. So looking at the left, the chance of having unusually wet is virtually nil. Really no chance of having unusually wet rainfall over the next few months. On the right, however, there's increased chance of 2 to 3 times more likely of being unusually dry. So we are looking in that kind of bottom 20% of the historical range over the next 3 months. So next, I'm going to cover off on what some of the Australian climate drivers are doing. Australian climate can be influenced by a number of large-scale climate drivers, as illustrated on this map here. These climate modes, like ENSO, the Indian Ocean Dipole, Madden-Julian Oscillation, and the Southern Annular Mode, can affect Australian climate on timescales from weeks to years. Sometimes they act together, sometimes they have competing signals. So we generally recommend relying on the dynamic model outputs, the ones that we've just gone through, because those take into account all of these influences and how they interact. But that said, it's still useful to understand how these climate modes may be playing into the outlooks. So starting with IOD-SAM and the Madden-Julian oscillation, the forecast for the IOD index on the left is showing actually quite an interesting pattern of warming towards a weak positive Indian Ocean dipole peaking in sort of June or July. So that's peaking quite early and dying off early. Now, if a positive IOD were to develop, that does tend to be a rainfall inhibiting phase, but it usually has a much stronger impact in spring rather than winter. So it's a bit unclear what role that'll play in the coming months. SAM, the Southern Annular Mode, describes the average position of the westerly wind belts, and that's currently weakly positive, but it's expected to remain in neutral territory over the next few weeks. SAM does not really have predictability beyond a few weeks, so that should not be a strong influence in the next month. Lastly, we have the Madden-Julian oscillation, the MJO. So that is this eastward pulse of rain and cloud that travels around the globe near the equator, and it circles the equator every 30 to 60 days. And depending on where it is and how strong it is, it can have various impacts, such as promoting cyclone development, which we are seeing a bit of right now. But it can also act to enhance El Nino development and also suppress rainfall over Australia, which are a bit of a current concern for the April-June period, as the MJO is expected to remain active as it moves into the Western Hemisphere over the next few weeks. So the lower right figure, it's not a forecast, but it's a historical composite of average rainfall conditions when the MJO is active in this phase that it's expected to go into. Now to ENSO, the El Nino Southern Oscillation. So currently, all indicators of ENSO are neutral or approaching neutral following the La Nina we had this past summer. So sea surface temperatures in the central tropical Pacific, that's what's on the upper left there, are currently average to slightly cooler than average at the moment. In the middle, the Bureau's Nino 3.4 forecast is expecting a strong and rapid warming trend in that central Pacific region where we define the El Nino index, the Nino 3.4 index. And what we can see on the right is the forecast of June sea surface temperatures showing this development of a fairly classic strong Eastern Pacific El Nino warm tongue. So this El Nino signal is a large part of what's driving the warmer and drier conditions that we're seeing in the outlooks over the next few months that we're just looking at. Now, staying on the El Nino for a moment, because I am aware that this is a trending topic, I just want to go over a bit of what we do and do not know about the development right now. So at the moment, the strongest indication of El Nino development is in the subsurface temperature anomalies. These are current subsurface temperature anomalies. Looking at this cross-section in the lower left, this is if we took a slice of the ocean along the equator. So the middle panel there is the Pacific Ocean from west to east, and as you move down in the graph, that's deeper in the ocean. So we're starting to see this warming at about 150 meters depth that's propagating eastward towards the Nino 3.4 and Nino 3 regions where we define the El Nino. However, that subsurface warming has yet to connect to the surface in the Central Eastern Pacific. So we're not seeing it at the surface yet, and that's why the Nino 3.4 index is still neutral. And if we look not just at the Bureau's model forecast, but 8 of the major international models, there is a pretty strong consensus among these models about El Nino developing towards the end of winter, noting that the Bureau's model is still leading the pack in how quickly it's developing and how strong it's expected to be. I still want to urge some caution here, though, because forecasts initialized at this time of year have lower predictability the further out we go. This is due to the nature of the climate system at this time of year, not the models. We call it the autumn predictability barrier. We're in a transition time when last year's climate driver cycles, like the La Nina, are breaking down and resetting, and the new cycle either hasn't begun or hasn't gotten enough momentum to lock in. So the analogy is we're a ball on top of a hill. And while all the models are picking up on some strong signals that the system wants to roll towards an El Nino, that development is very sensitive right now to short-term disruptions like cyclones and wind bursts, which can either send the ball rolling in a different direction or reinforce the current development. So we'll be watching for both ocean and atmospheric indicators to couple in the coming months before any event is declared. So while yes, it is looking very likely that there may be strong warming in the tropical Central Pacific, indicative of El Nino, it isn't just that Nino 3.4 index that we're watching. It's winds and cloudiness and pressure gradients, because it's through those changes that we get impacts on our weather here in Australia. So even if an El Nino or a positive IOD event is called, even if the atmosphere couples, every event is different and has a wide range of impacts and spatial patterns here in Australia. And this is why we encourage use of these integrated seasonal forecast outlooks over the climate driver indices as predictors, because they take all of these indicators into account, and they provide a probability on the likely scenarios. And when we do look at those precipitation scenarios out to June, there is a bit more spread in the multi-model comparison on those outcomes than in the Nino index that we're looking at here, the Nino index itself. So now I will move on to our drought forecast, which does use those dynamical seasonal forecasts, the outlooks from the Bureau that we went through, as inputs into the drought forecast. So here we have a drought forecast out to 3 months ahead using the combined drought indicator. This forecast was initiated on March 31st, and it shows the most likely CDI category at the end of each month out to June 30th. Below each map, there is a blue map on the left, which shows the ensemble agreement. So going back to the forecast explainer earlier, this is what percentage of the model's 99 runs agree on the outcome that we're seeing in the drought map. So dark blue means that at least 75% of the ensemble agrees on the CDI category that's been predicted. The green map on the right shows the past skill of the forecast for predictions made at this time of year, where darker green indicates higher skill. So what this forecast is showing is that conditions are holding relatively steady through the end of April compared to what Kel showed earlier as the current conditions. But as we move into May, we're seeing an intensification of conditions in the Central West, the Central Tablelands, and the Hunter, and further expansion of drought conditions into the Southeast and North Coast. These conditions are expected to largely hold through June. So the forecast for these expanded conditions is being driven by a mix of factors, including these long-term soil moisture deficits, ineffective and spatially variable rainfall patterns for production, and those increased chance of below median rainfall outlook that we're seeing over the next 3 months. So now I'm going to hand back to Kel, because he'll go back over a few of those locations in a bit more detail.
Great. Thank you, Jen. Very comprehensive analysis of the forecast. So thinking back to those 4 sites that we walked through a little earlier, as I mentioned, the time series, which shows us that value of tracking those underlying indicators, looking at this on a reasonably regular basis every month or so, just to see the trend. That's what you're seeing on the left. So I'm just repeating that from earlier. On the right is that site analysis for the drought forecast that Jen just went through. So you'll see the three lines at the top, the rainfall, soil water, and plant growth. You'll see some very fine colour lines either side of that darker line. That indicates the model runs that Jen talked about, or that ensemble run. So you can see the spread based on each time the model was run. And then at the bottom, for those time periods, starting on the 15th of April and every sort of 2 weeks, 30th of April, middle of May, middle of June, end of June, the most likely category that this site will be in, most likely CDI category that this site will be in at those periods in time. So for us, again, we can start to get a bit of an insight about which of those indicators is driving that forecast, coupled with the Bureau's forecast that Jen talked about. And as you can see, we're seeing here some really low rainfall and plant growth responses over the next 3 months, or a further decline in those indicators, which is going to see that current drought-affected category remain over the next 3 months, which was reflected in that overall series of forecasts that Jen showed there earlier. If we skip forward to Gilgandra, again, we saw that sharp decline here at the end of March into early April, and again, it's a really low rainfall indicator, which is impacting soil water and plant growth. So again, it's that rainfall deficit that we talked about, the combination of that with the drier outlook, or the below median chance of rainfall, which is going to keep the Gilgandra area, or this site location, in drought affected, with a roughly sort of nearly 50% chance as we get there towards the end of June of possibly slipping into the more intense drought category. Going forward to Menindee, that really strong response that I talked about there earlier from those rainfall events in February and March will be sustained. So, the forecast is saying that the rainfall that will fall, those indicators are high enough to maintain and sustain that recovery, and that region or that location will remain in a non-drought category through to the end of June at this point. Finally, Tumut, it's those combinations of things that we talked about before. We've been in a prolonged drought scenario for that part of the state. That rainfall isn't enough to sustain or prompt any recovery of any note, and all the indicators are already low, and they're going to remain low based on those combinations of factors that Jen talked about in the forecast. So a continuation of drought conditions for the Tumut region. So in summary, autumn rainfall remains a critical factor for much of New South Wales, and it will govern the strength of recovery. So as Jen alluded to in the forecast, it's a drier outlook at this point, but that's not necessarily the scenario. We will still get some weather events. It's just what they are like, and where the intensity and where that rain falls, is going to drive that continued recovery, and it's going to continue to direct decisions for producers in their particular enterprise and program. There's a lot of variability at the farm scale. I mentioned the summer deficits, and this opportunity now where producers are really starting to focus on optimizing risk as they go forward. And as we know, there's other external pressures that are now contributing to decision making, which is adding another level of complexity to an already difficult situation for some producers. Just a quick note, there are a lot of access to drought support measures, and Jeff and the team have access to all of that and can talk you through that. So we won't go through that. But in terms of more information and resources from our end, we are the Seasonal Conditions and Monitoring Program. We do have a suite of tools. As Anthony mentioned earlier, the monthly state seasonal update is where you'll find all of our information linked in one place, with lots of tabs, lots of menus, and lots of ways to access all of our information. There is the map, which is also interactive. You can go online and drill down and have a look at those individual time series for a location. Farm Tracker app, which we haven't gone through in a great detail tonight, which is a mobile app where you can upload your own information, take a photo of your site and load that into the report for that site for that period. As an administrator of the Farm Tracker system, we internally in the team can see the data that comes through in those reports, look at photos, and start to get a feel for what's happening on the ground. So that's a really useful little handy app that you can have on your phone and do a report at any time for any place. And we do have a whole range of other data and information and maps in our seasonal conditions information portal, which again is all online and accessible through the state seasonal update. Signing up for the SSU, as we mentioned, if you're on, that's a screenshot of the page. There's the big button at the top that says sign up for the SSU. It's simply a case of putting in an email, agreeing to the terms and conditions of our privacy policy or reading them and hitting submit. And as we mentioned, that was to come out today. So if you were to register tonight when I send out the email to say that that report has gone live, you'll be able to access that tomorrow. And finally, there's a whole raft of useful resources there that we've mentioned tonight. Some we've mentioned, some we haven't, but they all kind of interrelate and can help you in part or all of that decision-making process that you need to do as we sort of navigate through the rest of autumn and into winter. So on behalf of the team, that brings our part of the presentation to an end. So I'd just like to quickly reiterate, thanks to LS and the team for giving us the opportunity, and thanks for joining us to get an insight into seasonal conditions in New South Wales.
Great, thanks, Cal and Jen. Yeah, very comprehensive summary of where we sit. Just remind people, if you've got a question, please jump into the Q&A and put a question in there. We don't actually have anything there at the moment, but we'll just give people a minute or so. Just while we're waiting perhaps for a question, Kel did run through some of these resources, but if you need support or are looking for resources to help make decisions over the next few months, we've got the New South Wales Drought Hub website, the QR code just there. There's a whole raft of resources, some planning tools, and access to support through the Rural Financial Counselling Service and other parts of government support. As Kel mentioned, the CDI or Combined Drought Indicator Map is the next one. You can drill into there and have a look at your own region and look at some historical data and help use those tools to make decisions over the next few months. We've got a QR code there for our confinement feeding guide. For those who are in the livestock game, it's one of our major tools we promote to help manage dry conditions, and it's been well adopted down in the southern parts of the state and probably right across the state, to be honest. So if you need access to some information about confinement feeding, that's a good place to start. And as Kel has just mentioned, the DPI Farm Tracker app can help give some background and some ground truthing to Kel and the team to see what's going on across the state. Just at this point, you guys must have been so comprehensive. We don't seem to have a lot of questions, although we do have one here. So from Kate, with the CDI map, it has a delay and doesn't always reflect on-ground conditions. Can you explain for all online why and how that works?
Yeah, I can cover that one. First of all, it's really important not to base the drought assessment entirely on the CDI map. The reason being is it's based on a 12-month aggregation, so it looks at conditions going back for 12 months, and then does the ranking that Kel explained. It's designed that way. It's always a balancing act between current conditions, are they a short-term anomaly and perturbation, or are they, have they set in? And so the 12-month aggregation is like a compromise between the real short-term indicators that Kel showed you, which are more instantaneous. They're more accurate in terms of explaining the last week, the last 3 weeks, the last 3 months. Those particular indicators can be highly volatile. They can change a lot. On the other hand, if we use the longer term indicator, it makes the whole thing less sensitive and there's even more of a delay. So in terms of the total assessment and recognising drought in a particular region, we really make sure we do a balanced assessment. We utilise those short-term indicators, as we, Kel sort of showed the logic of that. Particularly at the moment, the assessment of drought entry in northern New South Wales, a very quick, rapid drought entry. The CDI had a delay for about 6 to 8 weeks, but in our total drought assessment, the sort of things you read in the state seasonal update, it's based on multiple indicators as well. So I hope that answers your question. Really, really important that you don't just look at the online map on its own. If you are, make sure you drill in and look at those time series. Those trends in the time series are really important, but also look at the state seasonal update and the short-term drought indicators, that 21-day soil moisture, the seasonal rainfall analysis. In this month's state seasonal update, we actually provide 3 months, 6 months, 12 months, out to 18 months rainfall, pasture growth, and soil water indicators as well. So, yeah, making sure we've got that handle on the short-term event and then give that balanced view about that medium-term drought event through the CDI.
Great, thanks, Anthony. Just another question here, probably for Jen, actually. Can you advise when that autumn barrier will ease and we can expect to see a better predictability or accuracy in the forecast and in the modelling going forward? When does that autumn barrier sort of break down and we get better predictability?
Yeah, thanks, Jeff. Yeah, that can vary a bit from year to year. Usually what happens is that those climate drivers do start to lock in. We'll see the El Nino development gain momentum. We might see the IOD development gain momentum, and that really improves predictability in our models. So kind of depending on the speed of those, we might start to see some more convergence and answers in the models by sort of late autumn, early winter. Especially this year with such strong signals, I expect we'll start to see things shaping up maybe a bit sooner rather than later.
Yep, great. Thanks, Jen. Looks like our Q&A is looking pretty quiet at the moment. Just see if we can get a couple more questions, perhaps, while people are thinking through that or typing them in. For those in the audience, we do have a survey here at the end of our for tonight's event. So really appreciate if people could scan that code and maybe go through the survey and just help us improve what we do. Let us know if you got a lot out of tonight or how we could improve or what even what topics you might like to see covered in the future. I might just leave that up there for the moment. And yeah, so that feedback that we receive through that QR code helps to form what we do in the future. Very good. So yeah, we must have covered things pretty well tonight, team, because we're not getting a lot of questions. And but I suppose the summary really is that to plan forward, plan for multiple scenarios, but probably on the drier side at this point in time. And that, yeah, we really need to keep our eye on the ball, particularly in that north and northern part of the state, as that dryness is creeping to the north. And often we see drought events will creep, west to east or north to south or south to north. And then we're in that pattern now. We're seeing that creeping to the north. So we really need to start planning and get ourselves in shape in the northern part of the state, if we haven't already done that. For our southern guys, we've been in a drier pattern for an extended period of time, and we had a little bit of recovery in the early autumn with some rain. We're going to try and make the most of that, running into winter, and then manage the rest of the season as it comes. I might just stop sharing that code now, and anything you guys like to add to that summary?
No, I think it's a pretty good one there, Jeff. Just like to again extend my thanks to everyone. What you've seen tonight is some pretty tough numbers. The intensity of that rainfall deficit in northern New South Wales, you shouldn't really understate that. Very intense, quick drought entry. The prolonged drought event, some recovery, as Jeff said, and some ongoing uncertainty. These things do get pretty stressful for people. There's a lot of pressures on people, a lot of pressures on everyone at the moment, worries and concerns, particularly around the cost of production going forward. These things have an impact on us all. Please don't hesitate to explore the types of drought support services, be they business support, well-being support, and really importantly, tap into your local communities, particularly our good colleagues in local land services. But really important, if you are feeling that stress, please reach out, have a look at what type of support is available. I can certainly say, been doing a bit of touring around South over the past 6 months with the drought coordinator, and people who have accessed financial counselling or wellbeing support have really appreciated and got a lot out of those types of initiatives.
Great, thanks, Anthony. And yeah, just a plug for our for local land services and the Drought Adoption Officer program for those regions who come under pressure. Please reach out to us, and we can offer advisory service, help you with some planning. We can do some farmer group meetings and offer that support locally as things progress throughout the season. I think, team, we're going to wrap up. I think we've no more questions. We've got our information across, I think, in pretty good format. So thank you, Anthony and Kel and Jen, for your work tonight. Just a quick plug for those who are funding our program is has been the funding provided by the Future Drought Fund with support from the Southern Innovation Hub based out of Wagga. And we thank those guys for their support, and thank everyone for coming along tonight and joining in. And I hope we were able to provide some relative information for the season going forward. And that might be us for tonight. So thank you.
Thank you, everyone.